Okay, this video will be over part 2, diluting concentrated solutions. This is going to be problem 7 through 10. This is the paper that's, this is page 1, it's over molarity. We've already done numbers 1 through 6 on the other video. This is starting on page 3. This is problem number 7. We're starting at part 2, diluting concentrated solutions. Similar to drink and juice mixes, some chemicals are bought and stored in concentrated solutions. They are diluted before they are used. When diluting a concentration, the number of moles stays constant, but the volume changes. All right, here's our formula. Molarity initial times volume initial equals molarity final times volume final. So where molarity 1 or molarity I is the initial or first molarity, volume I is the initial volume, molarity F is the final molarity, and volume F is the final or second volume. All right, problem number 7. If you diluted a 1 molar NaOH solution to 0.1 liters of 0.5 molar NaOH solution, how much volume did you start with? All right, so we'll start with drawing the formula. Mi or M1 V1 equals M2 V2. Now, it doesn't really matter if you do I or F. I know I kind of switch back and forth, but you need to be used to seeing both. So it's good to kind of see both. They have I and F. Our green periodic table shows 1 and 2. It doesn't really matter as long as you understand initial means first and final means last or second in this case. All right, so if you diluted 1 molar NaOH solution to 0.10 liters. All right, so you started with 1 molar and you ended with 0.1 liters of 0.5 molar. This is going to be your final, or let's see, hold on over here. This right here is going from this to this. So if it's going to this, this is going to be final or second. And this will be your first or initial. How much volume did you start with? So it's already got it spelled out for us. Our M1, our beginning one right here, 1.0. It doesn't really matter if you're at 1.0 or just 1. It all goes in the calculator the same way. It's just I'm going to make it match so you can see where this number is coming from. Okay, our initial molarity is 1. The question is saying how much volume did you start with? So we're still looking for volume 1. If that bothers you that it's volume 1 and you want it to be an X like it is in algebra class, just make it an X. It won't hurt a thing. Okay, molarity 2, your new molarity, 0.5 times your new volume, 0.10. Okay, and it has the variables listed for us over here. The final volume and the final molarity. That's molarity, that's volume. Okay, and now basic algebra. Don't overthink this. Solve for volume 1. So 1 times volume 1, well, times 1, that's just volume 1, equals 0.5 times 0.1 equals 0.05. And this is liters of sodium hydroxide. Like I said, these problems a lot easier than the other ones. Okay, that was problem number 7. Now we've just got 8, 9, and 10. These won't take nearly as long as they took on 1 through 6. All right, number 8. What is the final concentration of 0.05 liters of a 0.2 molar NiCl2 solution is diluted to a volume of 0.1 liters? Okay, so we have Mi Vi or M1 V1 equals M2 or MF VF or M2 V2, whatever you prefer. Okay, so what is the final concentration? So the final concentration, that'll be the final molarity. That's what we're solving for, so that's going to stay as that because that's what the question wants to know. If a 0.5 liter if 0.05 liters of a 0.2 molar solution are diluted. So these two numbers go together. You have 0.05 liters, so your volume 0.05 of a 0.2 molar. So our beginning molarity 0.20 is diluted to a volume. Our new volume is 0.10. Okay, now basic algebra, don't overthink this. Okay, these two just multiply together. So we have 0.2 times 0.05 equals 0.01. Okay, divide both sides by 0.0. We'll out of room a little bit here. All right, so those cancel each other out. This over this is like 1 over 1. It just goes away. And then don't overthink this. Just let the calculator do it. We've already got this number in the calculator. Over means divided by 0.1 equals 0.1. And this is molar NiCl2. Okay. Number 9. If 50 milliliters of a 2 molar H2SO4 solution is diluted to a volume of 200 milliliters, what is the final molarity of the solution? This would be a good place to pause the video. Make sure you can do this. It does have converting milliliters to liters, so that's just moving the decimal 3 places back. Go ahead and pause the video, see if you can work this problem on your own, and when you're done, hit play, see if you got it right. All right, let's see if we can solve this. M1V1 equals M2V2. If 50 milliliters of a 2 molar H2S solution is diluted to a volume of this, what is the final molarity? So final molarity is what we're going to solve for. So that's going to stay M2. And then we have 50 milliliters of a 2 molar H2SO4. So these two go together. This will be our beginning. Our beginning molarity is 2.00, or just 2, times 50 equals, molarity 2 is what we're solving for, and 200. Do you see what mistake I've already made? I didn't convert to milliliters. These two numbers need to be, given in milliliters, and I need to be in liters. So I'm going to rewrite this and convert to that. So back 3 places, 1, 2, 3, 0.050 equals M2, and then 1, 2, 3, 0.200. Okay, all that is doing what it's asking you to do here. I really should have done that at the beginning, but I didn't. This is 0.05. This is 0.2. All right, basic algebra. Don't overthink it. 2 times 0.05 equals 0.1 equals M2 times 0.02. Divide both sides by 0.02. Those go away. And then we have M2 equals, we've got 0.1 in the calculator, divided by 0.2, 0.5. And this is the final molarity of H2SO4. All right, last one, number 10. If you prepare 0.25 liters of a 0.948 molar hydrochloric acid solution from a 4.74 molar HCl solution, how much initial volume did you dilute? How much initial volume? Initial volume is volume 1. So that's what the question wants to know. So that's what's going to stay as volume 1. You prepare this much at this rate, so those two go together, and that's going to be your final. So your molarity is 0.948 molar times, and this is already in liters, so 0.25 And then our initial molarity right here, 4.74. Okay, solve for volume 1. Point 948 times 0.25 equals 0.237. Divide both sides by 4.74. Volume 1 equals, okay, I've already got that number in the calculator. This big long line means divided by 4.74. Oops, hold on. 4.74. Did that mess it up in the calculator? Yes, it did. Hold on. 0.237 divided by 4.74 equals 0.05 liters of hydrochloric acid. I know that wasn't a lot of practice problems, but hopefully that gives you an idea of how to do these math calculations.